Today we're going to be talking about inositol. Inositol is kind of in the no man's land. It was once referred to or sometimes called vitamin B8, although technically it's not a B vitamin. Initially when it was discovered, it was thought that it was an essential nutrient, but we've come to find out later that the body can actually make inositol, upwards of about 4 grams. In some cases, 4 grams a day can be synthesized inside of your body. That being said, many people don't synthesize adequate quantities, and low inositol levels have been linked to a number of different conditions, which we'll get into. Now, some of the best food sources if you're trying to eat inositol, very simply, meats. We've got citrus, melons, leafy greens, bananas, almonds, peas, peanuts, and sunflower seeds. Now, citrus is true except for lemon. Lemon will not be a great source, but the other citrus will be. So if you're looking to increase inositol in your diet, and we'll talk more about why you might want to do that. We'll get into that in a minute. Check these foods out. Now let's talk about some of the functions of inositol. One of the primary jobs is in something called cell signaling. In biology, there's something called second messengers. Now, second messengers, generally speaking, what happens if you've got a normal cell here, there's generally cells have receptors, and so this is a receptor, and let's just call this a hormone. The hormone will bind to that receptor and it will stimulate a message into the cell. Inositol will pick that message up, and in some cases it will deliver more information to the DNA. In other cases it can take that information to a place in your cell called the ER, the endoplasmic reticulum, and then that can lead to a cascade of different events that help regulate different functions in different cells. So when we talk about cell signaling, it's actually the hormonal message that the cell receives, and then from there inositol delivers that message anteriorly into the cell. So a lot of different functions rely on this mechanism. We also need inositol for the regulation of blood sugar. Specifically plays a role in insulin sensitivity. Now if you've ever heard of a diabetic losing their ability to be sensitive to insulin, meaning they're making more insulin in an effort to override the loss of sensitivity. That's insulin sensitivity. This is where diabetes starts. Inositol plays a major role in that. It's responsible for fat metabolism in the liver. One of the original aspects of the discovery of inositol is that an absence of it leads to fatty liver disease. Now, you may have heard me discuss this as well because we've talked in the past about other nutrients like choline and vitamin B12. These deficiencies can also contribute to fatty liver disease. So if you're not a drinker, if you don't consume alcohol on a regular basis, and you've been diagnosed with fatty liver, you're definitely going to want to ask your doctor about the potential of whether or not inositol is contributing to that. Also choline and B12, and since we're on that topic, gluten. Gluten sensitivity can lead to a fatty liver as well. So again, those of you who don't drink alcohol but have been diagnosed with non-alcoholic fatty liver disease, these are things you just might want to think about in terms of why that liver is storing excessive fat. And again, inositol plays a role in lipid metabolism or in fat metabolism, so it helps to prevent that from happening. We know that inositol plays a role in its ability to help with neurotransmitter signaling. So it's one of the reasons why inositol is linked to diseases like anxiety and depression. We know that it plays a role in calcium regulation. And actually, this is one of those roles here. Calcium plays a role inside of the cell. So inositol as a secondary messenger helps, in some cases, helps for the release of calcium and creating a regulatory effect on the influx of calcium into certain areas of the cell so that they can work properly.